All right, so as you can no doubtly see behind me, this video is on single replacement reactions, also known as single displacement reactions. These reactions, like the name implies, deal with a single element. So in this type of reaction, one element is going to replace a second element in a compound. Your reactants are going to be an element and a compound. So you'll always see a single element and a compound, and your products become a different element and a different compound. So it takes this general form of T plus RS gives you TS plus R. One element boots the other element out. In a single placement reaction, an element replaces another element from a compound, and this is done in aqueous solution. So you're going to have things in water that are reacting. For a single replacement reaction to occur, the element that's displaced must be less active than the element that's doing the displacing. Another name for this kind of reaction is the scumbag reaction. You know, you should go to the date with one person, you leave with a different person. So we'll put my drawing skills to the test here. Mohawk dude. Girl sees Mohawk dude. And they end up with Mohawk dude came in and displaced spiky hair guy. Now spiky hair guy's leaving dance by himself. So you have a single replacement reaction. How do we know if an element's going to be more reactive or not? What we do is we look at the reactivity series. On the back of your periodic table is a reactivity series right in the middle. So I'm going to hold it up to the camera. Right in the middle there, that is your reactivity series. This reactivity series lets us predict whether or not a single replacement reaction is going to occur. In order for the element to replace the other element in the compound, it has to be higher up on that activity series. So for instance, if you have a compound like lead chloride and you react it with lithium, lithium is higher up on the activity series than lead, so lithium will replace the lead. But if you had lead chloride and you put a piece of gold in there, because gold is lower than lead on the activity series, the reaction doesn't occur. So in order for the reaction to occur, the free element has to be higher up on that activity series. The free metal has to be higher up on that activity series than the metal that's in the compound. So these are some examples of single replacement reactions. You have aluminum and iron nitrate. Aluminum is higher up than iron on that activity series, so it will replace the iron. It boots it out. You can also have water or hydrogen be replaced. Hydrogen acts like a metal, remember? So you can have different elements reacting with water to displace hydrogen. Hydrogen can also be found in acids. So you'll have metals that will replace hydrogen reacting with an acid. And there's also sometimes halogens that can be replaced. If you look on the very bottom, you have a non-metal halogen reactivity series. So you can have nonmetals replace other nonmetals as well. So let's take a look at this example. Predict the products of the single replacement reaction. We have aluminum and copper chloride. So let's solve this problem out. I have my aluminum and my copper chloride. And we're going to see if this is going to react. So the way I figure out if this reacts or not, I look at my activity series. I find copper and I find aluminum. If aluminum is higher up than copper on the activity series, the reaction occurs. So I look and I see that copper is almost on the bottom. It's the sixth element from the bottom of the activity series, and aluminum is definitely above it. So aluminum is going to replace copper. So if I write out this, we're going to end up with aluminum chloride and copper metal. Now we're not done here yet. We got to balance this equation. Plus, we got to make sure that we have the right formula. Remember, we figure out formulas by looking at charges. Aluminum is in group 13, so it has a +3 charge on it. If we look here, chlorine always has a -1 charge on it. And that's the two that we care about. If we wanted to figure out copper, we could see that there's 2 chlorines, each with a -1 charge, so we have an overall -2 charge, which means that copper had to be a +2. But we don't really care about the copper in this case. We're just looking at aluminum and chlorine. We have aluminum with a +3, chlorine with a -1, so we get aluminum chloride as AlCl3, and then our copper metal. So now let's write the balanced equation. And if we're going to balance this, we're going to need to put a 2 there. We're going to need to put a 3 here. We're going to have to put a 2 there. And we're going to need a 3 here. This is the 100% correct answer for this problem. This is the answer I'm going to be looking for on your homework quiz. This is the answer I'm going to be looking for on your exams. A complete balanced equation with the proper products that have been predicted. Next, we have iron 3 and tin oxide. So, for this one, we know that we have iron, and it's our +3 ion, and we have tin oxide. We know oxygen is a -2, there's 2 of them, so we have -4 overall charge, which means tin has to have a +4 charge on it. Now we got to see if this is going to happen or not. So we find tin. Tin is about halfway up the activity series. We look to see is iron above it. Iron indeed is above tin on the activity series, so this reaction occurs. So the iron is going to boot tin out. So to do that, we end up with Fe2O3 plus tin. Remember, I got my iron oxide by looking at the charges on iron and oxygen. Iron's a +3, oxygen's a -2. Cross them over, Fe2O3. That's our formula. You have to be able to make these formulas. This has to become second nature for you in this course. If this starts being difficult for you, you need to reach out to me and get some extra help as soon as you can. In fact, that's what this upcoming Red Day is going to be all about. It's an extra help day for whatever you think you need extra help on. So now that we have our base equation, let's rewrite it and balance it. So 4Fe plus 3SnO2 goes to 2Fe2O3 plus 3Sn. And that is our balanced final answer. We're going to need to practice this a lot. I understand that. We're going to have a lot of practice built in this upcoming week. Let's try one more example. We have gold 4 adding it to iron oxide. So we have to decide, is gold going to replace iron or not? So we'll bring it down. We have our gold. And we have iron oxide. That has to be a +6, which means this has to be a +3 because there's 2 of them. And does this reaction occur? So we look at our activity series and we see gold is the very bottom element on there. So gold there's not going to replace iron at all. So we don't even have to predict the products for this one. We can just write no reaction. Or if you want to abbreviate it, you can write NR. Either answer means the same thing to me. So there's no reaction for this one. Don't have to balance it. Don't have to predict any products. It doesn't happen, so we can just write no reaction. Why isn't it going forward? That's the end. Those are the last of the examples that we're going to do. So like I said, if you are having issues, make sure you do reach out to me sooner rather than later. So that way we can make sure that we get everything taken care of. This week in class, you're doing an activity series lab where you're actually recreating this activity series so you can see where it's coming from. So good luck with your practice. And like I said, if you have questions, make sure you reach out to me.